Hi, I'm Katrina Dela Cruz from grade 12 St. Thomas. I'm going to explain what is light waves. The term light waves can be used differently by different people. Physicists tend to casually use light waves to mean exactly the same as electromagnetic waves. But most non-physicists do not. So, what is the difference? Electromagnetic waves are the waves made of oscillating magnetic and electric field and include radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Like all waves, they can carry energy, and that energy can be very high intensity. When looking at the visible light spectrum, the blue end of the electromagnetic spectrum is high frequency, high energy, and short wavelength. The red end of the electromagnetic spectrum is low frequency, low energy, and low wavelength. So what is light? Light is just one part of the electromagnetic spectrum, the part that our eyes can see. So when most people talk about light waves, this is what they mean. However, in physics, light waves often refer to any and all waves in the electromagnetic spectrum. And this is what we will discuss in this lesson. There are different types of light waves. First is radio waves. Radio waves are most commonly used in communication to send signals from one place to another. Radio waves are used in cell phones, televisions, and wireless networking. Due to the long wavelengths of radio waves, they can be bounced off the Earth's ionosphere, allowing radio waves to transmit their broadcast over long distance without being line of sight of all the listeners. Second is microwaves, are the next closest to the red end of the spectrum. You can probably guess that microwaves are used in our kitchen microwaves to cook your food. They are high enough energy that they can increase the motion of the molecules in your food without ionizing the atoms. The third is infrared. Infrared has a wavelength just a little longer than what our eyes can detect. The human body has a temperature that produces radiation in this part of the spectrum. And so, infrared detectors can be used as a night vision cameras. Infrared is also used by remote controls. Ultraviolet, or often shortened to UV. Heading into the blue side of the electromagnetic spectrum, which is the high energy and short in wavelength side. Ultraviolet is just a little too short in wavelength for our eyes to detect. UV waves are high enough energy that they are capable of ionizing atoms, breaking molecules bonds, and even damaging DNA molecules. For this reason, it is UV that causes sunburn and skin cancer. Most of the sun's harmful UV waves are absorbed by the atmosphere and the ozone layer. Lastly, X-rays. X-rays are very high energy and like UV. They can ionize atoms in the body and cause damage. However, at the right wavelengths and in the right quantities, they can be safely bounced off the body tissues to create the X-ray images of the inside of the body. X-rays are also created by neutron stars, black holes, and nebulae, and X-ray telescopes, therefore useful in astrophysics research. So this is all I have, and thank you for listening.